Let's have an introduction to differential equations. First, what is a differential equation? It's an equation involving a derivative, because to differentiate a function is to take its derivative. So a differential equation is an equation that involves derivatives. Examples would be dy dx equals x squared, or y double prime plus 2y equals cosine 4x. Maybe it'll have several derivatives in it. Here's the big idea of the course. We can use differential equations to analyze phenomena that are changing, because derivatives, the change represents the change in a function. For example, we could use it to analyze the electrical current in a wire, the flow of air around an airplane wing, population of fish in a lake, the rate at which one chemical compound turns into another, or the number of people infected with a disease. These are all realistic applications of differential equations, not bogus ones that you sometimes see in textbooks. Let's talk about the solution to a differential equation. Find a solution to the differential equation dy dx equals x squared. Think about what this means. We're saying we have some function y, and the derivative of the function is x squared. Okay, what's a function that has x squared as its derivative? How about x cubed over 3? The derivative dy dx would be x squared. And more generally, x cubed over 3 plus c. This one's a little trickier. Find a solution to the differential equation dy dx equals y. Again, think about what this means. We have a function y, and when we take the derivative of that function y, we just get y back. Can you think of a function that's its own derivative? You take the derivative of the function, and you get the same function back. How about e to the x? E to the x is its own derivative. The derivative dy dx is simply e to the x. So again, dy dx equals y. The derivative of the function, I mean, you can draw this out if you want to, y equals e to the x. So dy dx, what's that? Dy dx, the derivative, that's just e to the x. Ha! Notice that dy dx equals y, because they're both equal to e to the x. More generally, the derivative is y equals c e to the x, because when you take the derivative of this function, the derivative of c e to the x is simply going to be c e to the x. So that would be the general solution of this differential equation, dy dx equals y. The order of a differential equation is the order of the highest derivative. Dy dx equals y is a first-order differential equation because it has a first derivative in it. By contrast, y double prime plus 4y prime plus 3y equals sine x is a second-order differential equation because the highest derivative, highest order of the derivative is 2. An ordinary differential equation is linear if it is of this form. Oh my goodness, we're just dumping the definitions on you today, aren't we? But you'll be fine. Okay, so you have some function of x, let's say a sub n of x times the nth derivative of y, plus some other function of x, let's call it a sub n minus 1 of x, times the n minus first derivative of y, plus blah, 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 plus a sub 2 of x times y double prime, plus a sub 1 of x times y prime, plus a sub 0 of x times y equals f of x. Again, you just have function of x times derivative of y equals some function of x. For instance, dy dx equals x is linear. It's pretty basic. It's something of this form. a1 of x, y prime, equals f of x. Because in this case, you don't really have, the function that's in front of the y is just 1. So you have this y prime equals x. Dy dx equals y would also be linear, because you can write it as dy dx, that's this term over here, in this case the function in front of the y prime, the dy dx is 1, minus y equals 0. So in this case, the function in front of the y is negative 1. And in this case, f of x is just plain 0. So that would be linear. This would also be linear. xy double prime, okay, this is your function of x in front of the y double prime, plus 4x to the 10th y prime. This would be your function 4x to the 10th, that's a sub 1 of x, plus 3y, okay, in this case 3, that's your function a sub 0 of x, equals sine x. So in this case, sine x would just be the f of x. So that's a linear differential equation. By contrast, y double prime plus 4y prime squared plus 3y equals sine x is not linear. Here's the problem. You can't have y prime squared. You can have some function of x times y prime, but you can't have y prime squared. That is not linear. Find the order of the differential equation and state whether it's linear or nonlinear. What do you think the order is? It's a third order differential equation because the highest derivative is the third derivative. Is it linear? This looks like a linear term. This is okay, function of x in front of y double prime. This looks fine, 3y prime up. I think that's problematic. This is not linear because you can't have y squared. If we scratch this out, then it would be linear. But yeah, we can't do that. So yeah, it's not linear. Let's talk about verifying a solution to a differential equation. What does that mean? Let's verify that y equals sine x is a solution to the differential equation y double prime plus y equals 0. Here's how we do that. So y equals sine x, that means y prime, the derivative is cosine x, y double prime is negative sine x. So let's plug those into this differential equation. Y double prime plus y is going to be, sine x plus negative sine x, which turns out to be 0. Y double prime plus y is indeed 0. So yeah, that is indeed a solution to the differential equation.